All right, so now that we talked about functions, we're going to talk about function notation, which is just more about interpretation than actual new mathematics for you. So when we talk about functions, we have this special way of writing things. And this I really more want you to look at and think about, maybe pause it and think about what this notation means before you actually look into this. So pause, think about it, and then come back with me. So when we look at this notation, this matches with this graph. And if you notice this F parentheses and then the number here, F, like how can F times -1 equal 3.5, but F times -2, normally we see parentheses, you're talking about multiplication. Here though, this is notation. The F is not saying multiply with the parentheses here. What it's actually saying is, if you look at the graph, and you look at this -2 and this 4. Well, how are those two related? Well, look at the points here on the graph. This point here is -2, 4. And we want to test, does this continue to work? So this was the x value, this is the y value. 0, 3. -1, 3.5. And 2, -1. So when we look at this function notation, what you really want to think about at this point is, okay, what's in that parentheses is your x value. What it's equal to is the y value. So what it's really doing is just listing out points. So filling in the blanks here, if you look at 3, well, you kind of have to estimate where this is at, and that's okay for now. Negative, I'll go with like -1.7. So f of 3 is equal to -1.7. Because this was the x, the blank was we're looking for the y. In this case, we're looking for the x value and we know the y value. So if the y value is 3, we have the point here at 0, but if you notice, we also have a second point here. So again, you kind of have to estimate maybe -2. I don't know, -2.8. So really, what function notation is showing is this x-y relationship. It's a way of listing our input values and our output values for our function machines. So when you're looking at this and interpreting the function notation, it has different pieces. And so normally when we have function notation, I kind of wish the boxes weren't here, so ignore those for a second. Normally we see this f of x equals to an equation, -3x plus 7 in this case. Each piece has a different part to the puzzle here. So this f portion here, it's not a variable like a normal variable where it's going to stand for a number. Instead, you think about people in general, we like to name things. People name their cars. First thing you do when you get a pet, you name it. So the f at the beginning there is the name of the function, not saying multiply this variable with this variable. It's the name of the function. So when we talk about our function machine, and I'll just sketch one quickly, we have our input, we have our output. The name of this particular machine is f. Maybe instead of f, we name the machine Fred. Then we would say Fred of x. We're just using kind of shorthand with that letter there instead. So the name of this machine is f. The value in parentheses, this x, is what you're going to plug into the function. So x is going to go in. What's going to happen in the machine, this is not the name of the function. It's the rule, sorry, this is the rule for the function. So the rule is what's going to happen inside the machine. So -3 x plus 7 describes what's going to happen when you plug a number in. Where are you going to plug it in? You're going to plug it in that x value. The output then we describe as this last box, this f of x, you'll see written f of x, the output value, that whole thing together, it just represents what's the y value. So again, when you say f of 1 equals, in this case, 4, this is the input. The whole thing represents is equal to the output, so that y value. So when I plug in 1, I get out 4. So if we use that same equation and we look at some function notation, just to give you an idea, when we see f of 2, we're saying this is the x value, this is the input value into our function machine. So sketching our machine, you don't have to use the machine, but I'm going to do it here just to give you that visual help. This is saying take 2 and input it into the machine. Which machine? Well, we look at the name. This is the F machine. So for the F machine, we're going to put in 2, and we're going to take it and put it in this equation. So where does it go? It goes in the spot where x was. -3 times 2 plus 7. Our output then is -6 plus 7 is 1. So f of 2 is equal to 1. We take the same thing and do it with the -5. So -5 goes in our machine. We do, this is the F machine still, you can see from the letter, -3 times -5 plus 7. So our answer output is 22. So f of -5, there's our solution. We want to write that solution as using the function notation. So f of -5, and how we pronounce this, I've been saying it but not telling you. How we pronounce it is you say f of, and then so like f of x, f of -5, f of whatever is in the parentheses. That's how you pronounce that correctly. So you now get a turn at evaluating function notation. So if you notice, there's two different functions here. One is named f and one is named g. Make sure you're using the right function at the right time. So pause it and try it. F of 3 would be plug in 3 into x, 3 squared minus 3 times 3. So that's 9 minus 9 is 0. So f of 3 equals 0. If we plug in again, so we're looking at the function name. -2 gets plugged into f. We do -2 squared minus 3 times -2. Notice how I'm putting parentheses because if I do -2 squared inside parentheses, it's actually positive 4. So 4 plus 6 equals 10. So f of -2 is 10. G of 3. Plug in 3 plus 7 is 10. So G of 3 equals 10. The last one here might be a little bit more confusing, but think about again, what does it mean in the parentheses? This is the input. So if we take that and put that in the machine, wherever we see x, we're going to put 3x plus 2. So we're going to plug in 3x plus 2 into the g function right there, and then write plus 7. It's kind of like substitution method from what we've done before. So this is 3x plus 9. So it may not always be a number. G of 3x plus 2 equals 3x plus 9. Oops, 3x plus 9. May not always be a number. It may be more of an expression. If you're plugging in an expression, you're going to get out potentially an expression. The last place we want to talk about function notation is just connecting it with the visual, so not just the algebraic. And so again, you want to think about input, output, and we're talking about f of x in general. Remember, f of x is equal to y, so the x value for our relationship is what's found inside the parentheses. Our y value is what it's equal to. So when we interpret what this is saying, and this was the example we started out with, when we say f of 2, we're saying this is the x value. So basically what you're trying to do is, this equal part is the y value. You're trying to figure out what goes in this blank according to the graph. You're starting with the x value. If we go to 2, comma, the point on the graph is 2, comma, -1. So f of 2 is equal to the y value, -1. If you look at this second statement, though, for what values of x does f of x equal 4? In this case, though, you're starting with the y value. So if you start with the y value, basically you're trying to fill in the blank again. What goes here, comma, 4. Looking at our graph, and it says values, there's only one value here that works, and that would be an x value of -2. So f of -2 equals 4. So this is more about interpreting, not about necessarily doing advanced calculations. It's interpreting what the notation is showing you, and that's what notation means. So you've got a graph here to try, pause, and try it on your own. Function g is what's graphed here. G of 8, so again, this is the x value. I want to fill in the blank for the y value. G of 8, I go to the value 8, comma, and this is at 8, comma 3. So the y value, x and the y value is 3. For what values of x does g of x equal 4? Well, 4 is your y value. We're looking for our x value, so we want to know what blank, comma 4. So if I go to a y value 4, how many points do I have? Well, here's a point where the y value equals 4. Here's a point, and almost off the screen is a point. So we look at the x values. X could be -10, -8, -6, or that looks like it's about at 7.5. So in this case, you notice there was one output, multiple inputs, but again, this is still a function, so function notation used for function. This is still a function, passes the vertical line test. So if I draw vertical lines or use my imaginary vertical line, passes the vertical line test, you could have the same or different inputs go to the same output. You just have to say every time I put in -10, I only get one output. So passes the vertical line test. Use the notation to help you just thinking about input, output, x's, and y's.